In this video abstract, I will talk about how we have used the real vernier caliper and the micrometer to be used in augmentation with the virtual tools to bring out the best of the real as well as the virtual simulations. What we like about the real equipment is that it provides students a very real and textual feeling to the physics of what we are trying to teach them or what they are trying to learn. Now, one example of a very good activity will be allowing students to perhaps use the micrometer and take a measurement of the thickness of their hair. Now, we use a tool called the Easy Java Simulation, which we feel has an excellent potential for creating active and experiential learning, supported by the communities such as Fukun Huang's NTNU forum, which has shared the source codes for many of these wonderful simulations, of which we have adapted them from. The three design features that we found that were particularly outstanding in allowing our students to learn better is, number one, a simple 2D is associated with the real equipment to be able to bring out the learning and direct association to the tools better, as well as a consistent control panel layout at the bottom of our simulation to allow students to be familiar very quickly. Now, the second design principle involves the hints that we have put in as checkbox, as well as the answers, so that the student can very quickly check what is their answers to their experimentation. As you can see from the external measurement, the student will need to clamp it in. And also the introduction of zero errors, which is not easily found in most other simulations, but we argue that this is critical to understanding micrometer as well as vernier calipers. Then the different version, the different scales of the vernier allows the student to figure out the different concepts involved in the vernier scale design. I will now make use of the other computer model, which is the micrometer, to illustrate the hints, the answers, as well as the zero error. And I'm going to check on the zoom. The third design feature is assessment of learning in terms of an input field. So if the student got the answer wrong, there will be feedbacks to guide the students to check whether the answer is correct. And if the answer is correct, they will give appropriate positive feedback.